In this session, we will look into the event loop. Before we do that, there is a need to know about the call stack, so I uploaded a video about the call stack in the previous lesson. If you haven't watched it yet, I recommend going and watching it first. The event loop is a really important concept, not only in Node.js but also in JavaScript environments, including browsers. Therefore, those studying other runtimes, such as Deno or Bun, as well as those doing web development, also need to know about the event loop. In the first video of this lecture, I compared JavaScript execution environments, such as Node.js, to this restaurant. I explained how Node.js, which is single-threaded, processes tasks in an asynchronous and non-blocking manner. If you do not remember this part, please watch that video again. Assuming that you remember the metaphor used in this video, I'll proceed into this one. Let's take a look at how this process, which was explained metaphorically as a restaurant, technically unfolds. This diagram represents the flow of Node.js execution and the relationships between its main components in a hierarchical manner. Let's see how a JavaScript program operates in the Node.js environment. The uppermost layer is the JavaScript code we wrote. This is where synchronous and asynchronous tasks start as the code executes. As the code runs, it is parsed by the V8 engine. Synchronous tasks are processed immediately, and asynchronous tasks are passed onto the lower layers. Next, we have the call stack, which is used by the V8 engine to run the JavaScript code. This is the concept I explained in the previous video. Synchronous tasks, that is, actions like customers purchasing drinks or snacks, are executed right here. The stack waits until it is emptied, which is until the line of customers is gone, before moving on to asynchronous tasks. The following step is where asynchronous tasks, essentially like passing the orders that require cooking onto the kitchen, come into play. Actions involving files, HTTP requests, timers, etc. are passed onto the kitchen, which is libiv. The final step is libiv. Libiv is the tool that enables Node.js to communicate with the operating system and process tasks quickly. Note that other JavaScript environments like browsers, Deno, Bun and others do not use libiv but use their own engines. In order for Node.js to operate on a computer, it should be able to interact with the operating system that computer uses. libiv serves as an intermediary in this, requesting the operating system to open files or network requests, and then passing the results back to Node.js.
So, depending on which operating system it runs, the tasks libiv performs will be different, right?
Correct. You could think of it as an interpreter who can speak 3 foreign languages. Asynchronous tasks are processed in the background by this libiv. A thread pool, simply put, is a place where multiple chefs process customer orders simultaneously. This is where asynchronous tasks are processed with multi-threading, and the event loop, the title of this lesson, is also included here. The event loop is like a waiter going between customers and the kitchen. When a customer orders a dish, it gives them a ticket, delivers the order to the kitchen, and then constantly checks the kitchen and calls the customer as soon as the dish is ready. Let's look at the way this event loop works, as if it's an employee doing his job. First, there's the phase where the program starts to run and the event loop is initialized. This is the moment when the restaurant doors open and the order staff prepare to serve customers. As JavaScript code begins to run, the synchronous code that is stacked in the call stack begins to be processed. Next is the phase where synchronous code in JavaScript is executed from the call stack. Here, we handle all the orders of customers who come to purchase drinks or snacks at once. Once the synchronous code is finished, we go over to the event loop to process the results of asynchronous tasks or pending callbacks. In the microtask phase, microtasks such as the then method of promise and the next tick function of the process, which we will discuss soon, are processed. This is a phase of handling high priority tasks, kind of like urgently packaging and bringing out food to customers. Event loop goes on to process tasks from the timer phase, continuously moving between the kitchen and customers. Here, the callback is executed when a timer set by set timeout or set interval has expired. It's like checking if there's food in the oven or microwave that has finished heating up. Since it can be checked after the given time has passed, it's not served exactly at the specified time. The pending phase is rarely processed, where tasks that could not be processed in the previous cycle are finally handled for various reasons. The poll phase is one of the most important phases in the event loop. It waits for the completion of asynchronous operations like reading files, receiving network responses, and executes the callback of completed tasks. As each dish is cooked in the kitchen, we call the waiting customers to come and pick it up. Lastly, there's the check phase. Here we execute setImmediateCallback to handle in the next example, wrap up one cycle, and go back to the timer phase. The event loop checks through the microtasks and each phase, and if there's nothing else to handle, it will finally terminate. Once all waiting customers and food awaiting in the kitchen are taken care of, the program fundamentally ends. Now, let's take a closer look at how a program works in Node.js through an example. The result of running the code on the left will be printed out on the terminal on the right. Please take a moment to review the code. I will use this space to show in text the states of memory, call stack, and task queue at each step of the program execution. This import statement is processed during the module loading process before code execution, so it is excluded from the process we will discuss here. Now, let's take a look at what happens as the code runs. So far, all three spaces are empty. First, this console log, which is synchronous code, goes into the call stack. Since it's not the code that calls another function, it is executed and removed from the call stack right away. Therefore, its result is printed out on the terminal first, as you can see. You can see that the corresponding code has disappeared from the call stack. The following code is process's next tick. This function registers a job to execute right after all the synchronous codes have been executed. I'll let you know when it's used, along with the example, in a moment. This function also gets registered into the call stack like so, and like the console log that was executed before, it comes out of the call stack while being executed. And the callback registered with this method goes into memory and the task queue. Memory is the space where this callback function itself is stored, and the task queue is a lineup to schedule when to execute it. It's as if the customers have picked up a number and moved to the waiting area. This callback that prints next tick as a log is like the food being cooked in the kitchen. Although the task queue is precisely divided according to the type of tasks, in this video, I'll represent it as a single space. Next is promises then method. This method also gets up on the call stack and immediately executes and exits. Then, as such, the callback function passed as an argument to this method also goes into the task queue and memory. As I've said before, the task view is divided by type. Because these two are on different lines, the order is not as it looks on the screen. These are the next tick queue and promise queue, both distinguished as a microtask queue. Next is the setTimeout method, set to execute after 0 seconds. The callback of setTimeout will go into the timer queue belonging to the macrotask queue. The macrotask queue has a lower priority than the microtask queue, so even if the time is specified as 0 seconds later, it will be executed later than the two callbacks registered earlier. Next is the setImmediate method. SetImmediate is used to pass a callback function that will be executed in the check phase, as I mentioned earlier. We will also discuss this function later. The callback function passed as an argument goes into the check queue. Next is the readFile function, which reads data asynchronously from a file. The callback function is also registered in the IO queue, which is a macrotask queue. The next one is synchronous code, console log. As a snack buying customer, that's why the results appear directly in the terminal. All the synchronous codes have been executed now. All the customers in the order line have finished ordering. Now the tasks waiting in the task queue will be processed priority-wise. According to current Node.js materials, next tick has higher priority than promise. However, this may vary depending on version and environment, so the results may differ in practice. The same is true for other things as well. Therefore, the callback function registered with then of the promise comes out of the task queue and enters the callback stack like this, and then it executes immediately, and the results appear in the terminal as shown on the right. Next is the function I put in with nextTick, a microtask, also going into the callback stack and executing. Next is a setImmediateCallback, a macro task. In my case, the sequence of setTimeout and readFile callbacks varied from test to test. Remember that depending on Node.js's details of operation, you may get different results each time. In this test, the readFile callback was executed first like this. Finally, you can see the setTimeout callback executing.
Even with zero latency and the timer phase being right after the microtask phase, this is the last one.
As I mentioned earlier, the latency value is a minimum, and setting it to 0 does not mean it runs immediately. You can think of it as the event loop doing some other things while pressing the microwave button, then checking the microwave. So, as we can see, the program we wrote in the code on the left operates through such a procedure and outputs in the order shown on the right. This might have been an experiment to peek into how Node.js internally runs the code. Some of you might be hearing about the process's nextTick function and the setImmediate function for the first time from the example we just discussed. We will wrap up the video by learning about these two functions. This example is a hypothetical real-world code, so I will only explain it without running it. Please take a moment to briefly pause the video and look at the code. As you see here, we import a virtual database related module and use it. The purpose of this code is to fetch user information from the database and update it in the cache at the same time. This work is carried out through this updateUserCache method. The method returns the user's information retrieved from the database like this. But before that, it also performs the task of updating the information in the cache. If it's a task to store in a remote place like Redis, it may take time. If this task is carried out synchronously, the return of user information will be delayed by the time it takes to save to the cache. That's why we use the nextTick function to solve this. If you pass the task to nextTick, it proceeds asynchronously after all synchronous codes are executed. I mentioned that nextTick, along with promises, is a microtask which has the highest priority among asynchronous tasks. So if you have a task that you don't want to interfere with the progress of important other work and pass it as an asynchronous task, you use this nextTick function when you want it to be handled first among asynchronous tasks. Here we have a practical example that uses the setImmediate function. Please take a moment to consider the use of recursion in this code. In this example, we've used a hypothetical library related to file uploads. The main function here is the process large file. It serves to upload large files in certain increments to a destination. This function checks for certain conditions, such as whether there is still data that needs processing, and if those conditions are met, it recursively executes itself. It keeps calling itself until all data is uploaded. However, if this operation was synchronous, the recursion would repeat itself without being able to proceed to the asynchronous phase of file uploading. Therefore, the part that calls itself is converted into an asynchronous operation using the setImmediate function. The reason why we use setImmediate instead of nextTick here is as follows. As mentioned, callbacks registered with nextTick are executed in the microtask phase. However, file uploading occurs in this poll phase. Therefore, if we make a recursive call in nextTick, there won't be a chance for the file upload to take place. So, we use the setImmediate function to run the callback in the check phase following the poll phase. By doing so, we allow for file uploads to occur between each recursive call, enabling the entire upload to be successful. We've covered some really important concepts in Node.js, including the event loop, libov, and additional functions. I'll see you in the next video.